Hi, everyone. Welcome back to 165CL. So we're in week 5 now. We're going to continue on with lab module 2. And what we're going to focus on today is we're going to sort of discuss our protocols very quickly about how we're going to do our heat treating and our hardness testing. And this is the sort of experiment where we're going to obtain the core data for this module. We're going to take 3 different samples, have them be exposed to different thermal histories, and along the way measure their hardness. Okay, remember this is a sort of stand-in for the strength of the material. So we'll also perform the experiment. Now, normally this would be when you would perform the experiment. Since we're virtual, this means you're going to watch me perform the experiment through the videos that I've posted. Okay. So just a reminder, our heat treatment plan is pretty simple. So there's sort of 3 main steps. We're going to heat our material to ensure that it's a single solid solution phase. This can be called solutionization. So this is at some high temperature. We're going to do 550 degrees Celsius for 3 hours. We're then going to quench our samples down, and then we're going to give them a precipitation heat treatment, or what's sometimes called an aging heat treatment. And we're going to do 3 different temperatures. Okay, we're going to do 200 degrees C, 150 degrees C. I'll correct that typo on my slide before I post them. And then 20 degrees C, so just room temperature, right? And remember, although 20 degrees C seems low, it actually is about 1/3 of the melting point of aluminum. And then we're going to do a battery of different times, okay? So we're going to measure at 0. So this would be right after quenching from this solutionization treatment. And then after we've been in this heat treatment for 1 through 5 hours, 24 hours, and then for the room temperature experiment, we're going to have a data point for 168 hours, which is 1 week. All right, so now's the time for you to go ahead and watch the video where I go through the different steps of the heat treatment needed for the aluminum copper alloy. You can get it at this link, or I also put the link on our Canvas page. What I'll work my way through is the solutionizing, quenching, do different heat treatments. I'll also mention how after our solutionization treatment, we had to polish the surface one more time because it had oxidized during the treatment. All right, so I'll pause for a second, go ahead and watch that, and then come on back here. Okay, so at each of those steps where I was at a given time point, I needed to take those samples and measure what its mechanical properties were at that instant. And remember, the way I did this was with something called hardness testing. So the idea is pretty simple. So if I have 2 materials and I scrape them against each other, I can look at which one scratched the other, okay? And the one that scratched the other one is harder, okay? It's a pretty hand-wavy qualitative sort of way of thinking about things. And this goes back to this sort of original way of scratch testing materials. A simple version of this you could think is if you have a penny and you scratch it, you wouldn't be able to scratch the penny, but the penny could make a scratch against your nail, okay? And then you can step up and think about how that works for different materials. And a good example is that diamond would be one of the hardest materials, right? Another sort of anecdotal way to think about this is why people used to take coins and would bite them to test if they were truly gold like they were supposed to be. People don't really do that. We don't even have real gold coins anymore, but you see a sort of remnant of that tradition or that habit in when people win an Olympic gold medal. There's sort of a very famous photograph that most Olympians will take, and that's them biting into it. It's just sort of signifying that they won gold, okay? Now, one thing about this sort of scale, this one term of taking these things and scratching them against each other is called the Mohs scale. The problem is it's not a good way to quantify the hardness of the material. For example, on the left here is a plot showing different little crystals that will have Mohs scale values from 1 through 10. But the problem is if you were to measure the true hardness, you would find that your diamond is not some small amount harder than corundum. It's about 3 times harder, okay? So you need to be more quantitative. There's different ways you could go about doing this. I'm just showing you a few different examples here These different tests, Brunel, Vickers, Knoop, and Rockwell, are really just differentiated by what's the shape of that tip that we're poking into our sample. So for example, Brunel is a sphere that we're pushing in. Vickers and Knoop are sharp tips that we're poking in. And then Rockwell is a cone. So it has perfect cylindrical symmetry, but it does have a sharp tip. Okay. So we're going to use one of the most common ones used in industry, and that's the Vickers microhardness. It's a pyramid-shaped indenter that looks like a diamond, that's made out of diamond. Again, the reason is that you want the indenter to be really hard so it doesn't deform. You want to deform your material. If we're looking at that, what that indent will look like, it will look like a square on our surface of our material. And we can go in and measure the size of that indent to quantify how hard our material is. Okay, the basic idea is shown here on the bottom left. So you come in and indent with a known force, you inspect it with a microscope, you can see that indent on the surface, and then you can measure those diagonals across the indent. All right, so now is the time to go ahead and watch our video of myself stepping you through some of the important processes of the hardness testing. I'll show you how we generally go and make indents, and then how, in this case, I'm using an optical microscope to go and measure batches of those indents. Okay, so after I did this for all of those different samples, by the way, this took me a long time, right? So each sample I needed to do a full set of time points over a day, and then one of the samples I let sit for a week before indenting it. Anyways, this is just showing an example of an array of indents. This is for the aluminum copper that was annealed at 200 degrees C for 5 hours. And what I did is each time I went in and measured what are the different dimensions. So in this case, I could measure the horizontal and vertical diagonals. In this case, these numbers were expressed by the software in terms of millimeters. So they're very small, but you can remember that this is also, I can convert this by moving this decimal point 1, 2, 3 spaces, and see that these are 30 and 31 microns across. Okay. All right. So what you'll find is a lot of data. So from all these a few dozen experiments compiled on an Excel worksheet, what you'll find is for each of those indents, so 5 per temperature and time combination, you'll find 2 width values. You can go and find that underneath our Files tab on Canvas. Now, that's sort of all we need to do today. We collected all that data. What we will do next week is look at how we can take that and use that to calculate a hardness. And then we can plot those hardness values and understand and analyze what's happening during this experiment. All right. So please make sure you're caught up on all the processes. Don't forget to start writing your report, right? You know the methods, you know the intro, you even can describe some of the results that have come out. We'll finish up the results with the hardness measurements and analysis next time. And then you'll only have that final discussion to finish up. All right. I will see everyone soon. And please, again, make sure to watch the videos, and I'll see you on either Wednesday or Friday for discussion.